Hello everyone, and welcome back to another video in my series on how to use AWS Lambda, .NET 6 and AWS SAM to build serverless applications on AWS. In this video, we're going to continue right off from where we left the last video where we were talking about unit tests. And in this video, we're going to touch on integration testing and a good software development lifecycle to get into to ensure that as a developer, you can be as productive as possible while still getting your code into the cloud and into production-like environments as quickly as possible. Don't try and bring the cloud to your IDE using emulators or the like. Take your code to the cloud as quickly as possible and run it in the place where it's going to run in production, because that's the truest way to test integrations. Let's get into the code. So the second part of testing is integration testing. We actually want to test in the cloud. And this is where I would normally do this in a separate project. So if I create a new XUnit project and we'll do hello world integration tests. And these integration tests are going to be slightly different because this is where we're actually going to interact with the actual API. So we've got our integration tests here. And our first test is get calling IP should return. Okay, so for the purposes of these tests, we're going to need an HTTP client. So if I create a new HTTP client, I'm actually going to use that in our test. So what we want to do quite simply is make a get request to, and the way I normally do this is we would pass this in as an API URL, and then we might have a default API URL. And then, so because we have no idea what the IP address of the Lambda function is going to be in the environment that it's executing, we can't test the body specifically. We can't test what the IP address is going to be because we just don't know. So all I'm simply going to do for the purposes of this test is to check that when we call that API URL, then we get an OK response. So when I actually go to run this integration test now, if I go into my tests directory, and hello world integration tests, and if I run that test now, I'm expecting an OK status response, but I actually get a bad request. Strange. So if I go and look at my function logic now, you see the opening line here actually is testing if my body is empty. Now, that is something that I didn't cover in my unit test. So by way of a software development lifecycle, if I go back to my function test now, and I actually add a test for what should happen if with empty body should return success, because if the body's empty, all I'm doing is asking for an IP address, so that should return successfully. If I go to my event helper now, I'm going to duplicate that API gateway request and say with empty body, and I'm actually going to update my body there to be completely empty. Go back into my tests, and when I serialize my body, there we are, I want that to be an API gateway request with an empty body. And if I go back to my unit test now, we would expect there to be one failure because I'm now passing in an empty body, but I'm expecting a successful response, and that should give us one error. Excellent. So if I go back to my function now and I remove that section at the top so I don't actually care if it is what I do want to check, instead of checking for an extra empty body, I want to actually check that the API gateway proxy reference dot HTTP method is equal to a get method. Is that coming in as a string? Yep, it's a string. So I want to check that that's get. And if it isn't a get, I want to return a 400 error. Okay, so if I test that again now, I should get 3 successful tests. And then the final thing I want to test is, of course, I got 2 failures because my other event helpers are actually making post requests. That should now be successful because we have got all GET requests. Excellent. And then by way of just testing the post request, if I just switch this bottom one here to be a post, and then post there, and then we can write one more test to make sure that a post request fails. So if I duplicate that again, function handler with post request should return 400, and then when I pause my body, I want to change that to an API gateway post request. I now have 4 pass tests. There we go. Excellent. So we've tested all the different variations of our business logic and how data can get into our business logic without actually making any network calls. If I now redeploy my function, because I know my unit tests work, and I'm actually going to do that using SAM sync. Yeah, missing stack name, and my stack name from my config file is .NET 6 sample. So we'll just set up SAM sync now. Yep, I'm happy for that to corrupt my cloud formation if it needs to. So SAM sync is running now, and what that means we can do is if we can open our integration test project, and we can run a .NET test. And now that that's synced, we've now got integration tests. Excellent. So in terms of software development lifecycle then with Lambda, how I tend to do things is keep SAM sync running all the time. So whenever I make a change, that's going to sync that code up to AWS. And what that then means I can do is if I then need to change my business logic here, let's say I make that say, let's say we had a status field to our API gateway, I'll make that change and that will instantly sync up to the AWS cloud. I'll then come and change my unit test to make sure my unit tests have that additional field. So I expect an OK status. I expect an OK status for that handler. I expect an OK status for that successful handler. And for my 400s, I don't expect the OK status. And I would do that, and I could then run my unit tests to make sure, at least at a really high level, that the code that is synced to AWS is meeting the requirements. Once I know that it does meet the requirements, which it does, I can then run my integration tests, and because what I've changed hasn't actually affected my integration tests, these will still pass. And you can see that's a really fast software development lifecycle. You know, it syncs my changes really quickly up to the cloud. I can run .NET test as soon as I want to test my local business logic, and once I'm ready to test in the cloud, I can run my integration tests. So that brings us to the end of what I wanted to talk about with testing. Test your business logic locally, test your integration tests in the cloud. Don't bring the cloud to your IDE, take your code to the cloud and get things running where they're going to run as quickly as possible. Because this is serverless technology and your code is only costing you money whilst it is executing, running your integration tests in the cloud is a really resilient but also cost-effective way of doing your integration tests in a production-like environment. In the next video, we're going to talk about SAM project structure. So what we've been working with so far are very simple, very rudimentary examples that don't really meet the requirements of an actual application. So we're going to build out a CRUD API using DynamoDB, and we're actually going to look how you would start to structure your project when working on a production application using .NET and AWS SAM. As always, like and subscribe if you enjoyed the video, and I will see you next time.